Hello, welcome to my bench. If this is your first time, hello, my name's Dave. I repair electronics and sometimes I build stuff like this. And if you're returning, welcome. Welcome back. Today we're going to take a look at the high voltage capacitor tester that I built in the previous video. I'll link it up there someplace. And we put it in a box. It's a nice little box. It's just exactly the right size, and we'll show you the inside here. I did a couple of things that I hadn't done before on the other just wired up with a bench thing. For one thing, I gave it a big red neon light. When it's on, big red neon light, because this thing will produce 600, almost 600 volts right there. And that could be kind of dangerous. So, you know, it's nice to know the thing is on. It did end up with a 3-position switch because that's what I ordered. It's not what I wanted, but it works out okay. So this switch is on, off, on. So the center position doesn't connect anything. And I've got it discharge this direction to discharge whatever cap you've got in there. And test is over there. On the front, I've got voltage adjust. Now, yeah, I know these are little stick-ons, and these are little, well, done with a Sharpie. I can get rid of those later. When and if I ever find a source for those little press-on or press-apply, or we used to use them all the time in kit building, where you had a little sheet of letters and numbers, and you could put it up there and rub a pencil or something on it, or a Q-tip or something, and it would transfer a perfectly made little number onto whatever you were doing, and they really work great. I got a couple of them here a while back, but they were so old that they just didn't work anymore. And I haven't been able to find a decent source for them. And I'll find some, and when I do, these will come off, and that'll come off, and it'll be labeled better. It's yeah, whatever. It is the way it is now, I guess. Some of the old stuff just isn't around anymore. If you can see this is labeled at that first one there is 50 volts. That's 100 volts, 200, 300, 400, 500, and it'll go to about 575 all the way up to the top. Only in the test position. On the front, this over here, this says current. This comes out as 1 volt per millivolt. So when you're measuring on your meter, you want to keep you want to measure this down into the microvolt range, and a good cap will have virtually nothing. But that's what that is. That's low voltage coming out of there. On the top, we've got the device under test. It's these guys. You just clamp it onto there, turn it on, and turn the value up. And this one is the voltage that's going across these, direct out, which you will be able to see on a meter. If you look up in the top left corner here, I've got 2 meters running. I've got the top one is going to be the current, and the bottom one's going to be the actual voltage that is present here. On the back, we've got an on-off switch, a scratch. Unfortunately, I can take care of that, I guess, with a little bit of paint. And one of those power connectors that has the fuse built right into it. I always save this kind of stuff from things that I tear apart, because you never know when you're going to need one. And since I finally got in my, where is it? Since I finally got this little nipper guy in, I can make square holes, which is great. Making square holes with a drill is nigh on impossible. So that's what makes that fit. This one's just a big round one. Anyhow, and on the bottom I found 4 sticky feet to replace all of them that were on here, because if you saw the other video, one of them was busted. So I just put these guys on here. These little guys here sticking through the bottom, those are the standoffs for the board inside. There's 3 of them. That one just wasn't viable to do it, so I left it out of there. So let's take it apart and take a look at the inside. As Dave says, don't turn it on, take it apart. It's held together with 4 little screws. I'll have a link in the bottom to this box if you want to get one of these. And I'll try to put a link. I'll put a link down there to the Antique Wireless Association, where you can buy the board. All right. Since these guys are up on top, I had to do some wiring. I tried to make it as pretty as I could, and as functional in case I have to get into it. So I added some. Anyhow, there's the inside. The big fat wires coming up here go to the stakes for this. I did use these pre-made terminals here that fit. Where is one? They fit these so that you can plug something into them. I like using these things. They're a little more expensive than individuals, but they go in there well, and they're very well isolated. The holes are quite large, the holes that these go through, but there's a little lip on the top and the bottom of these. Let's see, do I have one here I can show you? Yeah, I think I do. Here we go. Yeah, this is one of those, by it's all done without being used, and we'll take it apart. They're good and long. They'll go through a healthy amount of stuff. Metal. If you look at the bottom here, you'll see there's a little raised lip. Well, that's how big your hole has to be, because there's a little raised lip on the bottom part here. So those come together, and you got a little gap in there, and that's what insulates them from the metal. So it's a good amount of insulation, and at 600 volts, I think. Well, this isn't going to jump. This is 600 volts at very little current. But these guys are, I like using these. And when you put them back together, they have a little brass washer that goes there. 2 of these guys, I don't know why. I've tried it doing in between the 2 nuts, and it just doesn't seem to work. Anyway, and they all come this way. Anyway, and you screw that down, and then you've got that little gap there for your metal. And then you screw the other one down as a lock nut, or for a spade going in there, or you can solder to the little terminals on the ends, which is what I do most of the time. Every once in a while, I'll go through the trouble of making a spade, but for something that's going to be never taken apart, I'll solder them on there with yeah, he says a good mechanical connection first. Yeah, okay. Anyway, so I use these in all the places so I can use a plug-in if I wanted to use a different kind of cable. It just makes it better. It fits. It's universal-ish. Anyhow, so in here we got the board in the bottom. You can see it. It's mounted all the way to the bottom of the box. Along this side here is where all of the inputs and outputs go from the, for the tester itself, and over on this side over here is your AC. This is grounded, so that I've got the input, neutral, and ground are right here, and they all come off of this plug. Like I said, this plug has a fuse built right into it. I think it's 250 milliamps on this thing. It's not much. You can get more of them. And this the switch back here, that's your on-off switch. This pot is a dual gang 500K, which controls your voltage. There's the it's on light, stupid, don't touch the things with your bare hands. And the cable's coming up here. This is, I forget what this is, 12 gauge? I think, yeah, 12 gauge coming up, which is way more than you actually need because, like I said, it's low current, but it's better safe than sorry. And then coming over here to your high voltage with no current at all, hardly, is some robbed out of computer wires, which work just fine. The rest of the wires in here are, oh, that's nice. The rest of the wires in here are all good quality, good quality wire, very flexible, and very easy to solder. But anyway, that's the inside of it. It's pretty good. Fits pretty well. Someday, when I got the money and or the time, well, mostly money because they're expensive, I want to get a nice meter. I'll take this out and put it over here or something, but I want to get a nice panel meter for voltage so that I don't have to have two meters hooked up to this thing, one for voltage and one for current, or, well, yeah, the current through the capacitor. Anyhow, there it is. It's all put together. And we'll screw it all back together here real quick, and we'll put it through its paces and see how it does. I think I may have even found a capacitor we can test that's not bad. It just leaks at higher voltage, which quite frankly it's supposed to, because I'm going to give it more voltage than it's made for. There it is. One more. Okay. Alright, so we're going to make sure it's off. Plug it in. I'm going to take the meter leads from this would be your bottom meter up on the left, and just clip lead them in here because I ran out of push-ins, banana jacks, and these go to the current sense in the front. So we are on off, and let's turn it on. Big bright hello light. See it? Yep. Hello light. It is off. That's off. That's discharged. So let's take something and test it real quick. I ran out of reds, so yellow is plus. Anyhow, this doesn't matter. This is not polarized. So we'll hook a device under test to there. Turn it on. Now you'll notice that when I do this, the bottom meter will go up to 9 volts. That's its lowest setting, so don't put anything 6.3 volts in here. But it'll go to 9, and we'll turn up the power here, the voltage. If you watch that meter, there we got 20, 30. That should be about 50. It gets pretty touchy down here, but there's about 50 volts. And the top meter says nothing. I mean, it's 0.0003. Let's put that on millivolts. And the millivolts is reading 0. I mean, it's nothing. The other one was actually negative. So let's take it up to, I don't know, 200 volts. It gave us, about 150 for a minute, and then went back to 0. There's 300 volts, so we're coming up. It's still reading 0. Negative, so that means it's not leaking at all. There's 400 volts. Still 0. These capacitors are 650. So there's 500 volts. Still reading -0. So let's discharge it. All right. So that capacitor is just fine. And if we want to test that against, against anything else, we'll find that it's just great. So let's take another one. Here's a greenie. Now this is a greenie. This is a 223 at 100 volts. So we can't go any higher than 100 volts on this. We're in discharge. All right. Get that out of the way. And we're down low. And we will go up to 100. There's 20, 30, 50, 90, 110. And you notice that the millivolts rating is still 0. I mean, there's nothing. So that's a good cap too. All right, off discharge. Turn the voltage down. All right, one more. Well, two more actually. We'll take this guy. This is a 47 microfarad. It is polarized. So the plus goes here. This goes here. Now this is a 450 volt polarized cap, 47 microfarads. We're down to 0. Now, if you watch your meter up there, the millivolt meter says 8, 12, 6, 4, 3, 2. It is dropping down like it's supposed to. All of your polarized caps will have a certain amount of leakage in the beginning until they charge up, and then they'll drop down slowly. You can go through the book and find out, or through the data sheet, and find out exactly what these are supposed to be. This one is sitting here slowly dropping down at 9 volts. Let's put this back on volts, because for a second, it will come up high on voltage. So watch your top meter. So we come up, see it went up to a half a volt and then dropped down. We're at 26. Went up to 1.19. It's dropping like it's supposed to. There is a permissible amount of leakage on these. I don't know what it is exactly for this, but if it's less than a millivolt, you're pretty good sure that it's okay. Some of them will be even better than that. Now, the bigger your cap with this, the longer it'll take to charge. That's why I picked a 47 rather than 1,000, because it takes a long time for 1,000 to charge up. So let's take it on up. Let's go up to about 200 volts. See it charge up? There's 200 volts. Yeah, really, really close. We're still at about 0.3. It's still rising. Let it settle off. See it drop? 0.1, 0.17, 0.16. It will drop eventually down to way less than a millivolt. It just takes it a while to do it, because that's the way these caps work. All right, let's take it up to its 400. There it goes. It popped up again like it's supposed to, and it's dropping back down 500 millivolts. Remember, 1 volt is a millivolt, so we're looking 300 microvolts, basically. Good cap. Nothing wrong with it. That is a permissible leakage at 400 volts. All right, now I'm going to put this, watch the bottom meter. It's at 387. That is a electrolytic, so it'll have a charge on it. I will turn it off and then turn it to discharge and watch it drop. So it is discharging that cap right where it's supposed to be, down to nothing. All right, now we're going to try, where'd you go? Here we are. Here's a little old green, I don't even know what this is supposed to be value-wise. Value doesn't mean anything in this. I don't know. Let's hook it up to this and see if we can see what this actually is. It is 77 nanofarads. All right, 77 nanofarads. That's what it's reading on this meter. So, let's hook it up. We are in discharge. Take our voltage down. And put those off to the side. All right, now let's watch your voltmeter over there. Not much happens when I just turn it on 9 volts. I would think so. Let's take this up to, I don't know. Take it up to 50. Somewhere around 50 volts. It's still reading just fine. All right, let's take it up to 100. It's still reading okay. Take it up to 200. Uh-oh. Yep, we're at 200 volts. And if we look, we've got 1 millivolt of leakage. Well, microamps, I guess. Microamps would be 1.2. That's leaky. That cap is leaking at 200 volts. Now, I would suspect so because I don't think that cap's rated at 200 volts. If we take it back down into what I think its range is, which is about 100, it's in the point microvolts range. So, but anyway, that just shows this thing will read a bad cap because I couldn't find any bad caps. I just don't keep them around. I mean, if it's a bad cap, I throw it away. Anyhow, turn it off, discharge it, and off. Okay, well, there you go. A very worthwhile build. Not a waste of time at all. This thing is very useful. It'll go on the bench and be used for lots of things, especially when I'm fixing these old ham radios and stuff, and I want to check the caps and see a breakdown voltage. So between this and just a regular cap meter and Mr. Carlson's leakage tester, I pretty much got everything covered here. Well, and the ESR. The ESR tester is very important also. So in order to do old caps, you really do need several things. Anyhow, hey, thanks guys for stopping by, and if you like the video, don't forget to give it a thumbs up and subscribe. By the way, I have a Patreon channel now. It's over at AERV blog on Patreon. If you feel like supporting my little hobby or habit or whatever it is, I haven't quite figured it out yet, you can do it over there, and I would much appreciate it. You get first view of the videos, and I'm also doing some lessons on components and how they work, and we'll get pretty deep into some of this stuff as things go, and those lessons will stay up on Patreon only. The other ones will be there for a couple of days, the repairs and the fix-its, and then they'll come over here to YouTube. But if you want to see them first, you can support me on Patreon. Thanks for stopping by. Hope to see you again. Till next time.